we go. It's recording and good. All right, so quick summary of where we were. Your question was this. I got it. You gotta get out of the way because Chris Laporte's got a class coming, but we'll get done fast. All right, so one of these limits exists, the other one doesn't. One of them has got a zero denominator you can't get rid of. Do you see it?
Yeah.
Which one? The top one. Because the top one, the x minus 5, is to the higher power. So I can cancel out a square root of each. But I'm left with a square root of 5 down here. So this one is a does not exist. Because you can't get rid of that zero denominator. Let's see in detail how to get that does not exist in case you're not seeing it. Well, one of the things you can do is just cancel out, and this thing is equal to 1 over the square root of x minus 5. So that's one way to see it. Or you can multiply top and bottom by the conjugate. This is a nice trick when you think you've got a play. Because now that top becomes x minus 5, buns naked, to cancel with this x minus 5. And I have the square root of x plus 5. Let me see if I did this right. Square root, I got, no, it's a square root of x squared. My fault. Square root of x squared minus 25. There we go. And that didn't help you any. Because the factor, the square root of x minus 5, you still have to factor it out and cancel. But this play sometimes works. In this case, because, think of it like this, the limit doesn't exist no matter what. So you try some bigger play. The limit doesn't exist. And that's what happens. You know? Okay? And then that one down there, that other one, I can do that play on that one, and I'll have x minus 5 to cancel with the x. Well, I'll still have to factor out the square root. But anyway, that's that one I'm going to have a 0. This one works out to be 0. Is that enough? Not enough. Be honest.
I don't get it.
Okay.
I don't know how to do that part. Where you, like, yeah.
It's per here. Oh, okay. The thing that's frustrating about it is this play, it's an option. I have a difference of squares, a minus b, a plus b. So it's a squared minus b squared down here. Sometimes that works. Sometimes it gives me something decent. In this case, all I'm left with is I still have square root of x minus 5, square root of x plus 5. I still have this. I still can cancel this. I can cancel just this much. That's all I'm left with no matter what I do. Even, multiplying by this other thing didn't help me. I have an x minus 5 here, square rooted. This guy's like worth x minus 5 square root squared. Let me write it like that.
So why'd you multiply by the square root of x plus 1?
Because sometimes that play works.
Okay.
But not on this one, because this limit doesn't exist already. Like, I'm trying to point out that I've got the square root of x minus 5 squared down here. So I can cancel out a square root of x minus 5 in the denominator, but there's still another one. I still got a piece of x minus 5 in the denominator. I can't get rid of it. So the limit won't exist. But there's other problems. I just didn't write one down. There's other problems where that move works. So I think one of your questions is, how do you know when, because there's book examples like this, how do you know when to multiply by a conjugate? Well, if you got a limit that it seems to exist, where you got a 0 over 0, and the problem has a square root, try the conjugate thing. So next class, I'll bring one in that's like that, okay? All right, anything else?
I have a question.
Go.
So when we did all the practice problems, like those three, why didn't we use that one thing that we memorized?
Oh, because that wasn't, they just asked for the limit.
They
Just asked for the limit. That's your quiz. The quiz, you just do the answer.
So the quiz won't have the thing.
Precise, it won't have epsilon-delta.
Would it say you need to prove it? Is that what you meant?
When you have to prove it, or say do epsilon-delta, yep.
Oh, okay.
I might do it as extra credit.
Wait, that would like specifically.
Oh, yeah, yeah. And this is like this all the way through calculus 1, 2, and 3.
Okay.
Sometimes there's a long way to do the problem, which we do when we want to establish that we're absolutely right. But then there's the way to do it when I just want the answer.
So all we're doing is solving for.
We're just taking the limit any way we can.
Oh, okay.
Precise definition is the underpinnings of calculus. It's what limit actually means. You don't have to do it the long way.
Okay.
All right.
Thank you.
For sure.
Sorry, I didn't hear you. Did you say like how to say?
How to say what?